Hi guys, welcome to Blessed Excellence Center. Be sure to subscribe to our center. Today we are looking at limiting reagents. The combination of limiting reagents and excess reagents leads to the formation of the product. Your presenter is E.B. Christian. Limiting reagent is the reagent that is completely consumed at the end of the reaction. It is the reactant that is of insufficient quantity that is usually exhausted at the end of the reaction. The reactants that is in excess supply will have some quantity left. The number of moles or mass of the limiting reagent is less than that of the excess reagent in a stoichiometrically balanced chemical equation. Hence, the limiting reagent is completely consumed at the end of a reaction. So you have a reaction like gold reacting with chlorine molecule to give you gold chloride. How do you know the limiting reagent? That is what we shall be considering in this video. Procedures for determining the limiting reagents. I. If the equation is not balanced, first balance it. 2. Calculate the available mole of each reactant by dividing the given mass of the reactants with the molar mass of the reagents. 3. Calculate the mole ratio for each reactant by dividing available mole with mole in a stoichiometrically balanced equation. 4. The reactant with the least number of mole is the limiting reagent. Now, if you are required to calculate the amount of reactant left, this is the formula you apply. So, calculate the number of mole of each reactant left using this formula. A equal to Na minus open bracket A times R close the bracket. Okay, good. Where A is amount of reactant left. Na is available mole of the reactants. A is number of mole of the reactants in a stoichiometrically balanced equation, while R is ratio of the mole of limiting reagent, that is mole ratio of limiting reagent. You will realize that the limiting reagent will have 0 mole left. Let's look at this. Amount of product formed. The mass of the limiting reagent is used to determine the amount of any of the product formed. So if you are asked to calculate any amount of the product formed, you are expected to use the mass of the limiting reagent for such calculation. So let's consider a question like this. Determine the limiting reagents in the reaction calcium carbide reacting with 2 moles of water to give you calcium hydroxide and ethyl as C2H2. If 4 grams of calcium carbide is mixed with 2 grams of water, what is the amount of reactant left? C. The amount of C2H2, that's ethyl, produced at the end of the reaction. So look at how we about it. Solution. The given mass of calcium carbide in the question is given to be 4 grams. Okay. Given mass of water in the question is also given to be 2.0 grams. Okay. Good. Now molar mass of calcium carbide is 64.10 grams per mole. Watch my video on how to calculate molar mass. You will know how it was calculated. Okay, good. Now molar mass of water is calculated to be 18.02 grams per mole. Now step 1 says balance the equation if it's not balanced. If you observe this equation very well, you will discover that this equation is already balanced. Watch my video on balancing chemical equation. You know how the equation is what balanced. Okay, good. Now step 2, calculate available mole. The formula for available mole is given mass of reactants all over molar mass of reactants. Remember, there are 2 reactants. Okay, reactant 1 and reactant 2. So you are expected to calculate the available mole of this reactant being calcium carbide and also the available mole of this reactant being water. Okay, good. Now let's proceed. Solution. Let's look at the solution to the question. Now we've seen this available mole. Okay, let's continue from there. And we have that available mole of calcium carbide being the first reactant will be the given mole of that reactant, which is calcium carbide, all over the molar mass of that same reactant. In the question, we have the given mass to be 4 grams, and then the molar mass we calculated it to be 64.1 gram. If you evaluate this, divide this by this, you're going to have 0.0624 mole, and that is the available mole of the first reactant, which is calcium carbide. Okay. Now the second reactant being water. Available mole of water is the given mass of water all over molar mass of water. So the given mass of water is 2. The molar mass of water is 18.02. If you divide this by this, you're going to have 0.111 mole, and that is available mole of water. The next thing is to calculate the mole ratio of the two reactants. Okay, good. And the formula for mole ratio is available mole of reactant that was calculated all over mole of reactant in a balanced equation. If you have equation like this, look at this equation now. In this equation, the mole in a stoichiometrical balance equation is the number written at the back here as the coefficient. So the mole of this calcium carbide in a stoichiometrical balance equation here is 1, and here is what? 2. Okay, good. So that is what we're going to use to calculate. Now, step 3, we are still on step 3, where we say mole ratio of reactant is equal to available mole of reactant all over mole of reactant in a balanced equation. So the mole ratio of calcium carbide will be the available mole of calcium carbide, which we've calculated to be 0.0624 mole. And then the mole of calcium carbide in a balanced equation, as I've shown you guys, is 1 mole. So if you divide this by this, you're going to have this value, which is 0.0624 mole. And that is the mole ratio of calcium carbide being the first reactant. Okay, now let's continue. The mole ratio of water being the second reactant will be the available mole of water all over the mole of water in a balanced equation. We calculated the available mole of water to be 0.111 mole. Okay, then in the mole of water in a stoichiometrically balanced equation, I showed you guys it is 2. Okay, so if you divide 0.111 by 2, you're going to have 0.0555 mole, and that is the mole ratio of water. Now, step 4 says, since the mole ratio of water is less than that of calcium carbide, it means that water is the limiting reagent. So if you compare the mole ratio of water, which is 0.0555, if you compare it with the mole ratio of calcium carbide, which is 0.0624, you see that this 0.0624 is greater than this 0.0555. Therefore, water is the limiting reagent. Now let's look at solution to B. Amount of reactant left. Step 5 says amount of reactant left is calculated by the formula available mole of the reactant minus number of mole of the reactant in a balanced equation times mole ratio of limiting reagents. Okay, good. So the amount of calcium carbide left will be equal to the available mole of calcium carbide minus the number of mole of calcium carbide in a balanced equation times the mole ratio of water, because water is the limiting reagent. Now, we've calculated the available mole of calcium carbide to be 0.0624. Okay, good. Then the mole of calcium carbide in a balanced equation, the stoichiometrically balanced equation, is 1. And then the mole ratio of limiting reagent being water is 0.0555. So if you evaluate the whole of this, you're going to have 0.0069 mole of calcium carbide. So that is the amount of calcium carbide that is left at the end of the reaction. Good. Now let's look at the amount of water that is left. We said the amount of water left is equal to available mole of water minus number of mole of water in a balanced equation times the mole ratio of water being the limiting reagent. So we calculated the available mole of water to be 0.111. Okay, and then the mole of water in a balanced equation, in a stoichiometrically balanced equation, is 2. So if you multiply by the mole ratio of water be the limiting reagent is 0.0555. If you evaluate the whole of this, you're going to have 0. That means water is the limiting reagent, so no amount of water is left at the end of the reaction. So let's look at the solution to C. C is asking us of the amount of ethane, that is C2H2, produced at the end of the reaction. Remember, you use the amount of the limiting reagents to determine the amount of product formed. Okay, good. Here step 6 says mass of limiting reagents is used to determine the amount of any product formed. Okay, good. Hence, since water is the limiting reagent, its mass is used to determine the amount of ethane produced at the end of the reaction. So look at it now. The molar mass of C2H2, that is ethane, is equal to 26.04 gram per mole. As I watch my video on how to calculate molar mass, so I know how those masses were calculated. Okay, good. Then the molar mass of 2 moles of water is 36.2 gram per mole. Now from the balanced equation, from this equation now we have calcium, 1 mole of calcium carbide reacting with 2 moles of water to give you 1 mole of calcium hydroxide and 1 mole of ethane. Okay, good. So we've calculated the molar mass of calcium carbide to be we've calculated the molar mass of calcium carbide to be 26.04 and the molar mass of 2 moles of water to be 36.02. So we have it that 36.02 gram per mole of water produces 26.04 gram of calcium of ethane, that is C2H2, which implies that 36.02 gram per mole of water is equal to 26.04 gram per mole of ethane. Therefore, 2 moles, remember that the given mass of water in the equation is 2 grams. So we have that. Therefore, 2 grams of water will be equal to cross multiply this 2 times this 26 divided by this 36. That's what we have here as 2 grams times 26.04 divide 36.02. So if you evaluate the whole of this, you're going to have 1.45 gram, and that is the amount of ethane left. So that is how you go about the calculation. Thanks for watching. If you've not subscribed to our channel, do it to subscribe. Drop your comment, like the video, do well to share it.